Okay, welcome everyone. My name is Robert Raszuk, and the original plan was to do it in Polish, but because we have many people who are not speaking fluently in Polish, I was asked to do it in English, so I try my best to do it this way. Of course, if you have any questions in the unlikely event of the question, please ask in Polish or in English or whichever language you like. Maybe in French we have some translators. So today I would like to talk about some ideas and state of the art for the customers who are approaching the V6 paradigm. And this presentation has been made, and I originally presented this to some customers in Tokyo in December, because these are actually the most actively ones looking for solutions. And the problems here are, I think, you are facing the same set of problems. And my point of this presentation is to give you some hints of what are the possibilities, what kind of solutions are clearly coming up out of the ITF, for example, in this particular space, and what are the general approach for V6 deployments. There is a whole bunch of acronyms on those slides, and I don't want you to get scared immediately looking at the agenda. And I'll try to explain at least some of them, what they mean, or at least highlight what is important out of them. This is just a little bit of the overall agenda. If you see the solutions in general, of course, one solution is to deploy V6 parallel. I have some comments about this, how easy and how doable this is. But our solution is to actually allow coexistence in the nice way, and actually the colleague from RIPE described a little bit about this before me, how to make sure that the V6 can coexist with V4 and the world is still turning. And some of the solutions, especially IVI, seems to be winning in this particular space. Other solutions, which I'm going to also talk about, is kind of extending the life of V4 more. Maybe some of you will say, oh, but this is basically something we should be not doing. I think that to some extent we need both, because a lot of customers still would like to grab all of those grandmothers sitting at homes with the Windows 2000 and let them serve the net. So these are the little bit agenda. So where the fun is happening? Pretty much, these are the working groups in ITF where the V6, V4 coexistence is taking place. As you can see, it's quite a lot of crowd. And Behave working group, Software working group, both have a different approaches. For example, Behave is doing pretty much IVI or translation solutions. Software is now focusing, after they originally came with the spec for the softwares, or for extending the V4 life. And V6 Ops is general overall V6 operations working group. The reason we are paying attention as the vendors, and we are closely working with other vendors on the same project, are the key customers who already face the wall. What does it mean basically, let's say for Comcast, that they face the wall? They are not able, in Comcast, let's take it back. In Comcast, the V6 was a must, not for the customers. V6 was a must for management, because all of the cable modems, there were so many of them that they cannot allocate the RFC 1918 space to cover all of them. And if you realize what it means is that you cannot build parallel planes of RFC 1918 space, because then your management system gets screwed up. So you have to have a really good way to address each cable modem and to be able to access the cable modem uniquely. And this was V6. That was the original reason why Comcast moved to V6. Now they are doing more. They want to extend this paradigm, have the V6 network being a transit network, but still allow customers to use the V4. That's why the solution called Dual Stack Lite, and now actually it is merged with the A plus P, which I'll describe later. The new name is A plus P Lite. is the solution actually for which Comcast is really looking for. Other big providers like NTT in Japan are actively want to deliver V6 to customers and assure, without losing the face, that the customers can still access V4 Internet. And scaling numbers, for example, Comcast scaling numbers are very modest. We can address them today pretty much without any problems. NTT scaling numbers are hundreds of magnitude more because they really expect to grow V6 use, and the boxes they are asking us to build are really huge, I would say. Another interesting network, it's in China, educational network, CERNET. CERNET is the pure IPv4, CERNET2 is pure IPv6. And they really wanted to interconnect those two networks. That's why the IVI solution was born. And it's working well. It works for the last at least 1 year and a half. And I'll talk about this as well. But before we go to the solutions, I was actually quite scared when I listened to the panel yesterday, when most people at the panel and in the room were trying to find the solution how to switch from V4 to V6. I don't think such a jump is going to happen at all, honestly. It's not the Juniper statement, it's my own statement. Monitoring what happened since the RFC of IPv6 was published, nothing happened at all. And there are many reasons for that, but one of the major reasons is that it's very difficult to have the V4 network, like the one train infrastructure and another train infrastructure, and jump between those two ad hoc, essentially. You have to have a way to interconnect them. And you have to have a way to not only interconnect them, but also allow for easy coexistence of both. Because if you build new one, you don't have enough train stops to actually cover the needs for the people, like the web pages or services on the internet. So that's why this presentation, or actually the efforts to design solutions, protocols, and tools to coexist V4 and V6 I think are so important at this point. And this is not really something which a couple of guys in Sunnyvale sat at the table and discovered. This is what customers came to us and said, the large ones, this is the way we want to do the service. And this is basically what our response is to deliver the service. So if you compare basically the V4, V6 to a train networks, you end up with picture a little bit like this. It's not Poland. If you travel to Asia, you perhaps know where traveling happens like this. It's not PowerPoint magic, it's real picture. But the V4 train, it's quite full today. But to get people to Shinkansen, you really need to have some good hubs. Another analogy is with the Airbus A380. It only can be served by a couple of airports. And nobody would fly 380 if you would not be able to transfer the luggage between the 737 and 380. The same with the IP payload of the packets. You have to transfer the payload of the packet between V4 and V6 in order for that to be end-to-end effective for the users. And when people say IPv4 addresses are over, this is just for the allocation point. And that's true, you heard it session ago. But I looked yesterday at the different IRR's policies, and most of them say in the documents that they will officially and legally allow to resell IPv4 address space when the pool is exhausted. So you can actually expect that the addresses will be sold on eBay or in any other ways. And that's why I don't think essentially that V4 is going to go away anytime soon. An interesting point is, if you are a big provider and you have actually /8s or /16s enough for the next 30 years, perhaps you don't have to bother about V6. That's a problem and a good thing for the provider, because as long as you have enough addresses to allocate to your customers, this is not your problem. And that's another reason why V6 is not taking off so much, because large providers still have a lot of addresses to be given. And that's actually, I think, one of the issues that we don't see the V6 happening so fast. And if you talk about the interconnects, as somebody pointed out yesterday very well, it's not just about packet passing. It's also about DNS and about routing. So such an interconnect point have to do all three. If you do just one, it doesn't do any good. But to have such an interconnect point, you don't have to build the V6 DNS infrastructure at all. The DNS application layer gateway is all what is required to synthesize Quad A record, which is the V6 DNS world, from the today's classic DNS. So, and this kind of code is kind of already mature. It's shipping for some time, both in public domain and in vendors. So there are solutions which are practically deployable to allow you to build to merge V4 and V6 for the users. If somebody asks me, what is the best approach to deploy V6? I would say it's very simple steps. First of all, acquire some address space. Then make your network to be dual stack. Basically, to run your network internally without any external exposure to run both V4 and V6. It basically involves enabling V6 in BGP, picking your favorite IGP for V6, either OSPF v3 or ISIS, which does both, and run it natively in your core. Then, next step is to think, how do you approach customers? Do you have enough address space? Do you have customers who really beg you for V6 for some reason? But that's following. And at the end, you end up with some gateways, either at the customer-facing edge or in your core, depending on the scale. And maybe in years to come, some customers will say, oh, I only want V6. The services on the internet already do a lot of V6. Good for me. Google is V6 enabled. I can live with this. But that's coming in years to come. So let's talk a little bit about the solutions which are currently on the table. Before I forget, there was one comment yesterday which I heard. Somebody was saying that it should be in the Komenda Główna interest to recommend IPv6 deployment because the NAT goes away. Well, surprise. There's already spec for V6 to V6 NAT. So that is not really the case anymore. I know all of us, and me included, are skeptical about using NAT. And there are many reasons for that. NAT has a lot of problems. It has problems with encrypted packets. It has problems with modifications to the payload, embedded IP addresses, and so on. I don't want to spend time now to mention all of them. But first, you have to understand that this is all about the stateful NAT. Solutions which are currently on the table are dual form. One is the stateful NAT, the classical NAT, and this is basically the battle of how to fit more translation into a single box, and the stateless NAT, which is kind of, I would say, well, not new invention in terms of technology, but new invention in terms of deployment, to design the NAT in such a way that it doesn't hold any state. And that is, there's no magic, no crystal ball. Basically, if you don't hold any state in the NAT, you have to hold the state in the packet. And that's the alternative. But in this case, the NAT scales pretty much indefinitely. And the RFC 2765 defined the original idea for the stateless translation. And the stateless translation, as I mentioned, is based on the fact that part of the V6 address is your V4 address. So NAT can basically lift the packet, strip some part of the address, leave the V4 portion, and send it out. In both ways, works the same way. But of course, to do that, you realize that you have to have enough IPv4 addresses for the customers. So this is gradual migration. If you are in the position of still having IPv4 addresses possible, stateless translation is a very good way to go. In fact, at the CERNET network in China, is using IVI mostly with stateless addresses between those two networks. And recently also in the Behave working group, the Fred Baker is issued a little bit draft trying to extend this RFC for the stateful mode as well, which is, in my opinion, a little bit killing the RFC original idea, but this is one of the drafts on the table. Little bit of NAT 101. These are the slides pretty much mostly for reference. I'm not sure if I should spend any time here, but just for terminology perspective, the NAT just modifies the source and destination address. NAT PT modifies also the port numbers. Some people use the name PAT, but I think in the industry this is kind of obsolete. We use NAT PT. And you have a combination to modify both the port numbers and protocol translations. So it's a NAT PT PT as far as the acronyms. The types of NAT, depending on the state keeping the NAT, and also on the possibility of any arbitrary servers to go back to the original source of the request, the first packet. So if you have the full cone NAT, that basically means once you open the first session to a server in the net, then any packet from any IP address and any source address to a given opened NAT port can send packets. Other flavors of this is the restricted cone NAT, that only packets with any port address can be sent with the source port address, but destination address has to be the same as the original one of the packets from the server one. The restricted cone NAT means there is only one session allowed between client and the server. Nobody else can try to go through the NAT on the way back. And the symmetric NAT is pretty much enforcing you for each particular connection, you establish a different mapping in the NAT system as well. And when we're talking about NAT, you often hear the term CGNs. So CGN means carrier-grade NAT. And these are the customers like NTT in Japan is asking mostly for that. You also hear the name medium carrier-grade NAT and so on. Different flavors depend on the scaling target. And And all of them, in this particular case, are doing the stateful translation, and they should support, when they are in stateful translation, all the recommendations to the UDP, TCP, ICMP, how NAT should deal with that kind of protocols and traffic. That's usually supported by pretty much all NAT vendors today. Nothing really to worry through. Of course, there are some issues with protocols. Some protocols really require application layer gateways to be built inside, not just DNS itself, but also the protocols. FTP can do passive, so this is not really required for FTP, but other protocols can. Another problem with NAT is that a lot of users, and these are the real numbers which we heard in one of the interim meetings for the Behave and Software Working Group in Montreal last fall, use static mapping on the NAT. I use at home static mapping, but apparently above 40% of users have a need to map statically some ports to the internal addressing schemes. And there are a couple of proposals on the table also to dynamically allow that to happen. For example, the port mapping protocol allows this to be done dynamically. What it seems to me that current answer from big customers is that they are just designing the web page and allowing users to log into a web page, click on the button, and open through the web page some ports for them, if you have a NAT inside your network. And that's exactly what Comcast did in US, for that matter. So this is another approach. Instead of dynamically allowing users to punch holes in your NAT, you can semi-control this through some web page. So this was a little bit of the terminology. Now let's talk about the solutions. What are solutions on the table? The IVI solution is the first one I would like to describe. In general, this is the model of the V6 and V4 networks. And the prerequisites for this is the NAT and the DNS application layer gateway. And by state, I mean basically dynamic per flow state in the NAT box. Stateless, I mentioned that you don't keep per packet or per session state in the NAT because you are using the notion of the mapped V6 address. And the stateful, you do the classic NAT as today with translating the flows and keeping the state of the flows in the NAT. Another issue with scaling the NAT itself is, for example, the modern applications can open, like iTunes or Google Map, can open hundreds of sessions, hundreds of flows in the same time to different destinations or for more performance enhancements. And that's what really is a pain for a NAT box, because for NAT, it is in the independent flow which he keeps state of. And you not only have the problem of number of those flows, but also when to time them out, when you can clean the given state when the flow stops. These are the basically challenges as far as the stateful NAT is concerned. And there are a couple of solutions on the table, pretty much from one of the French guys, from Fred, and now also the IVI solution, which was originally designed by Professor Li, not Tony Li, but other Professor Li from China. He also kind of signs after that and supports in the Behave working group. So let's talk a little bit about this solution. As you can see, this was originally designed for interconnection of the two CERNET networks. One network, it's decent size, 20 million users in China of the university, just university users. And the CERNET2 has 500,000 today. These are the numbers which are running live. Somebody is starting questions are welcome anytime, any language we can speak, not Chinese. And they mostly use the stateless translation. So in fact, there is even the web page which you can log in if the network will be working, which is inside the V6 network somewhere here. We can log in from anywhere, any IPv4 in the world, and use the services today. So this is live proof that it actually works. Just a PowerPoint which you can draw anything. And the stateful one is the V6 to V4 direction, when basically somebody insists, I don't want to have a mapped address, or I don't have enough IPv4 addresses to use for mapping business, then you can actually do the stateful translation on the same very box between two clouds. They didn't want to support the direction of any IPv4 to any IPv6. And they said, we don't see a reason for that, for doing this. The technology is there to do this, because it is complicated, first of all, because it requires also changes to whatever you advertise in the DNS, and much more stateful translation in the NAT itself. And in general, industry is mixed. As my observation is, if this particular direction is useful or not to be done, to let the V4 access resources of any V6 addresses. I'm not sure yet. For that, it works. If you really have some servers on the V6 space, you don't have to allocate the mapped V6 address to all of your PCs. But if you have a server, why not to allocate the mapped IPv6 address to a server? And then the problem goes away. Everybody from the V4 world can access your resources if you advertise the service in the V4 DNS. And the entire stateless translation is, the magic comes in the V6 address, because V4 is embedded inside. And you have many different options on the table where to put the v4 address. And most of the proposals basically differ of this location of the v4 address inside the v6 header, essentially. The most popular ones I drawn, and I think this is the space where your input to the IETF community is required or interesting to see what if the protocol is specified today, it should be specified to either be flexible and allow one customer to issue /38 and then put the v4 address, the other do something else, or be fixed. And at this point, I think there is no consensus because network varies by size, by interest, by providers, where to put the v4 address. So I think it will stay to be flexible. And as far as the DNS, what I mentioned before, you have to do the application layer gateway. Just if you enable v6 today to some customer, if he wants to use the v4 servers, you have to translate DNS record to quad A record. And this is pretty simple because you just add the v6 portion of the address at the translation. In fact, this is not, no one specified this in any draft, but you can do a lot of good magic with the DNS ALG. Because if you have a control of which exit point your customers will go, to which NAT box your customers will go, even at the stateful translation, you can load balance the traffic between different NAT boxes easily. But so far, if you just do the simple single exit paradigm or any cast exit paradigm, so it's redundant, you don't have to do any magic on the DNS ALG. And the IVI solution, as I mentioned, is kind of, I think, coming up out of the translation solutions as the leader. Maybe in IETF in San Francisco that will change, but I don't expect that to change too dramatically in this particular Behave working group. The IVI implementation itself is available for download. If you want to play with this on Linux, they have the drivers for the Linux kernel and the entire implementation, including the DNS ALG, to be downloadable if you just want to play with technology in your lab or even in your network. So now let's talk about totally different approach and try to see how can we extend the life for the v4 more. And there are many different proposals. Two of them, I think, are getting more momentum than the others. And it seems to me that those will, at the end of the day, perhaps be shipping and implemented by vendors. It's not there yet. We are actually actively working with customers to fine-tune and find out exactly what needs to be implemented and how. That's mentioned about the Comcast case, that it is not so much of the need to push the v6 for the end users, but they just don't have enough v4 addresses for even the management plane. So that was the original issue for them. So one proposal they basically came up with was DS Lite. DS Lite stands for Dual Stack Lite. What it really means. Dual stack means that your device, your host, or the CPE, because those actually solutions will be designed based on the host and the CPEs, are capable of doing both v4 and v6. But what is Lite? Lite means that they only get the v6 address allocated. They could get v4 address if you have such address to give them, but you don't, so they are dual stack capable. They can run dual stack, but they only have v6 address to play with externally. Internally, they can have v4 address, no problem, but this is not external v4 address. And the idea is to share the v4 addresses or to enhance how they are statistically multiplexed in the NAT to more customers, essentially. by translation, by stateful translation. Because this is the v4 world. It's basically 32 to 32 translation. So this is no stateless magic here. Stateless is only in the translation solutions. This is tunneling solutions and full regular NAT solutions. The difference between the DS Lite and the A+P, I'm going to talk about in a second, is pretty much dual. One is what is the address, what is the amount of addresses of v4 available to users, and what is the trick A+P proposed. And the second is where do we place the NAT box? Should the NAT box be in the middle of the provider, or should the NAT box be as close to the user as possible? So those are the aspects to keep in mind as far as the tunneling solutions. And one important thing, when I talk about tunneling, some people get the high blood pressure because the tunneling means something bad by design. But I think this is a misnomer. Tunneling originally was meaning something bad because you have to build the tunnel and then send the packets through the tunnel. But this is no longer the case. When I'm talking about tunneling here, and not me, anybody in the industry, when talks about tunneling these days, they talk about just encapsulation in the header. There is no signaling involved. There is no state in the network for a given tunnel. This is just a new encapsulation. And that was basically, that changed in about 2001, where the MGRE solutions were designed, when the GRE header was dynamically built from the BGP next hop, and you can put the packet to a tunnel pretty much line rate on the fly, depending on your hardware, of course. But I want to underline this fact that the tunneling here is just an encapsulation. There is no protocol to signal the tunnel, like, for example, RSDPTE for that matter. And the tunneling here is done pretty much for two reasons, if you have that solution in mind. If you have a network, which is, let's say, v6 network, you have to provide some way of bridging v4 users through the v6 network transparently to a v4 NAT. That's one reason for the tunnel. The other reason for a tunnel is if you have a network which is dual stack and you don't want to pollute it with any of the customer prefixes, either v4 or v6, you tunnel it so the network stays clean. And that's exactly the reasons for tunneling in this space. And these are some examples. With these solutions, actually, as I mentioned, you can do this tunneling extensions to the CPE or directly to the host. And this is the basic dual stack Lite proposal, which pretty much, I don't want to go through all the details of the addresses. This is for your reference. But it basically means that you have the IPv4 packet coming to your CPE. It's tunneled to a NAT, which is here in the middle of the network. That's the place for the carrier grade NAT. It's translated to an outside address, which is a legal address, and sent to any server in the net. On the way back, it's pretty much the same. It's symmetrical. The same can be done if you have a tunnel directly coming from the host. And originally, I was very skeptical about this, but when I hear more and more providers saying that we have no problem to actually push some little application to the PC when they buy the service, this can be done very transparently for the users as well. So that should not be really the issue. Important thing to note also is that in those solutions, the address of the PCs can be really the same for all of your users. So it will be terrible for police department to find out who generated the packet because everybody will be coming from the same address. And in fact, there is a request for IANA registry to allocate /30 for this particular application. So the user PC, user operating system, is fully v4. It has the address allocated by IANA, and the same address is for everyone. And then it's just tunneled through the v6 tunnel to a NAT. And NAT has the role to actually optimize the statistical multiplexing of the whatever is left in the IPv4 space. And that's basically what this dual stack light solution is about. As I mentioned before, the port mappings are done through the web page in this solution. So this is something for us, the vendors, we don't actually do. But if you think that in this kind of solutions, we should provide some dynamic way for the users to punch holes in your NAT boxes, let us know. We can perhaps talk about this offline or revisit our current thinking. The basic encapsulation proposed currently in the software for those tunneling is IP in IP, so pretty much v4 in v6. If you require some more, perhaps L2TP will be the choice. The GRE currently, for some reason of the software working group, is not a recommended encapsulation. I don't know why. So now, let's slightly move to the A+P proposal, which is a new idea, relatively new idea, because I first heard about it in summer last year, and it was designed by a couple of guys in university and in IIJ in Japan. It is interesting to also observe that the tunneling solution have one very important benefit, that they can allow you to build the concept of the virtual ISP model, where, for example, if my provider of Neostrada, I will not say who it is, will not deliver me v6 service, I can build a tunnel transparently to NTT in Japan and have the v6 address available through that tunnel for my CE or any Linux box or Mac. So that's exactly, even for your internally, something to think about if you would like to start providing such a service for whoever is interested to subscribe. In fact, for this tunnel concrete example to Japan, the fee for monthly fee is about $6 or $7. And actually, that's good to mention. The currently in Japan, pretty much everybody is getting still v4 address, but for 10% more of the price, you can have an option on the web page to click and also get the v6 address for the 100 meg FTTH or DSL service, or plain fiber service to the houses. No DSL. DSL is obsolete already there. So that's one of the options which tunneling can provide you to get even more customers, more services deployed. So what is the A+P? A+P is the idea to hack even more IPv4 world and steal bits from port numbers. Because UDP and TCP have some notion of the ports, and if you observe that some of those ports can be hacked and divided to still leave something for the applications, and rest combined with the IPv4 address, then you see that for each IPv4 address, global IPv4 address, you still have more than one customer to be assigned. And A+P solution also works as far as to the hosts and to the CPEs. In my opinion, to the CPEs it makes sense, because if you have a customer, and this is pretty much for new customers, not for the old existing customers. Existing customers can operate fine. But for the new customers, you ship them CPEs, and it's already capable of understanding the allocation of address and the block of ports. And its user doesn't have a clue what he is getting in his bag, just plugs to the cable and he works fine. Because outside of that CPE would be a normal IPv4 address he is getting. So this is contained to your own network as the provider network. And the dilemma is, how many bits can we steal? Can we steal 4 bits, 80 bits from the port numbers? Because there are only 2 octets, right? 2 bytes of the ports. And currently, that number, it's kind of flexible. So what we see today is the solution of dual stack light and A+P have merged together. And on the example, this is the same example as I had before, except that this CPE is getting address of 133.15.10.24 and the range of ports to translate the packets. And if you push the translation to the CPEs, it actually scales very well, because the number of traffic generated by a single user, usually it's much less than the even low-end router can support. And here in the NAT, in the middle of the network, you pretty much don't do anything. You transparently strip the header, and on the way back, because it's mapped address of the tunnel endpoint contains the V6 tunnel endpoint contains this address. It's automatically assigned. So this is also stateless in that regard. So you do the translation here and the stateless translation here. So here is also easy for the user to open ports statically and allow for pretty much more easier application transparency. For those who were in Krakow at the first PLNOG, you saw Randy proposing basically something similar like this, I believe. So this is the example of the combined solution, and I think the new name now is A+P Lite. Last time I spoke to Randy about this. So this is the summary of this last solution. Pretty much I spoke about all of this. Some things for discussion. Usually when we talk about the set of solutions, it's nice to talk about what are the discussions about constraints of each solution. So incremental deployability, it's very important. Many customers, well actually all customers said, but all of the solutions are good, but we will not go now to the users and say, oh, you have to change your CPU, you have to change your operating system, forget it. So these are pretty much for new customers. When you are approaching the exhaustion of the V4 space in your network and you think that you will not get more or you will not be able to buy more because it may be really expensive. In fact, at the NZNOG this spring, I had such a big amount of dollars for /24 they were talking about. You have to basically keep in mind that for new users, you can have some solutions easy to deploy. You don't want to essentially put the big NATs in the middle of the network because it's a pain. It's a pain for you to support because with each application, you'll have to upgrade it to support new ALG for that matter. Plus, you have the issues with applications which don't work well through the NAT. Although it's less and less of them because NAT is everywhere, whether we like it or not, but that's the reality. Transparency through the intermediate devices, just like I mentioned at the last slide, the middle NAT boxes do not hold any state, just stripping the header and encapsulating on the way back. Of course, the network itself should be transparent. In fact, when we're talking about all of these solutions, the solution is about the CPE, maybe host, and perhaps some NAT boxes in the interconnectivity between other networks. So this is not really a router talk because routers completely are orthogonal to this entire business. The routers in the network stay as is, and you don't have to touch them pretty much at all. Efficiency vs complexity. Of course, the simpler solution, the better. So you don't have to worry about troubleshooting nightmares of something going bad and users coming to you and asking why this is not working and why the other one not working. As far as translation, double NAT should be avoided. Just like in the airports, you should avoid multiple hubs because your likelihood of losing luggage is greater, especially if you go from Frankfurt. Sorry. And we should encourage the V6 deployments, but pretty much in a way that the users can benefit day one when they get the v6 address. Not that they can only go to the free websites and be done browsing the internet, but also to encourage the use of that for normal v4 world. Of course, if you have users who want to just interconnect themselves, they can do fine just getting the v6 addresses and building the tunnels between them. That is totally different application, but that's not really the internet application. And the last couple of pages are about the standards work. This is just for your reference. I will not go through them. This is just if you want to sit down and get deep into the topic since the very beginning. I just listed number of RFCs which are talking about the v6 itself, how basically the numbering of the v6, how the numbering gets obsolete year after year, recommendation for the numbering, and some background for the DNS changes, the proposal basically for modifications to the DNS to support v6 as well as the DNS application layer gateways support. And the set of RFCs and proposals to do the v6, v4 tunneling, and other couple of recommended readings to actually, these are the documents actually which are quite interesting, which combine review of all other proposals, at least this is the desire of those documents, to combine review of all proposals into one document. So if you want, for example, to start looking at this space altogether, that's actually draft wing. I found when I read it quite interesting and good information. So that's pretty much it, I believe. These are some acknowledgements for people helping with the slides, reviewing this, and for information taken to the slides. As the final summary, I think that the deployment of v6 as the originally proposed in IETF is just not happening for obvious reasons, and alternatives which I try to at least highlight are one of the options to consider as far as moving with v6 to a wider scale. So thank you very much. If you have any questions, don't hesitate to ask now or at the break, or send me the email to my address, which is raszuk@juniper.net.